Hi, this is David Lady, and I'm the author of the Information Technology System Cookbook. This is a short video with PowerPoint slides introducing some of the framing concepts within the TrizIT methodology. The book, of course, is available on Amazon.com. It's very easy to buy, and I'd love it if you bought a copy. Giving dues where dues are owed. The first slide in any presentation I do is always a quick recap of Triz, or Trees if your Russian is any good. I'm a Westerner though, so I've Westernized it and I call it Triz, just like I call my framework TrizIT or TrizIT. However, the original Triz was developed post-World War II in the Soviet Union by a gentleman named Ginrich Alschuler. And you can search for him on the internet. There's a lot of information available. This is not his biography by any stretch of the imagination. But it is interesting to note the approach he took as he developed Triz, especially because with TrizIT, I've really started with his foundation and modified it in a meaningful way to address current information technology systems. What Alschuler did, today we call pattern cluster analysis. It wasn't called that when he did it, and the approach and methodology has evolved in the past 60 or so years. But what it basically is looking at formal approaches to solving problems, which is typically what a pattern is, categorizing them, abstracting them, and then looking for patterns in the approach to the different problems that were solved or the different contradictions that were dealt with within a system. We'll define both of those later. He found there was basically 40 generic solutions inside of engineering, which is what the problems that he was solving, what he was dealing with, generically, that if you could understand and categorize the specific problem you were dealing with, or the specific contradiction, you could abstract that, look for the generic patterns that he had found, apply those patterns to your specific problem, and see if it leads to an innovative solution. There are many examples of this. Triz has been around for a long time. There are many folks who consider themselves the steward in Alschuler's absence. But that's basically the foundation that we start with in TrizIT, and it's also fairly interesting. It's a fairly interesting field, and it's interesting to go out and research and see the evolution and the founding of this idea. As you get into TrizIT or Triz, you'll discover that you start to look at problems differently. And this is both a curse and a blessing. The big challenge is that as you start to remove the clutter and attack and be able to tackle the problems and apply solutions to them, you now are faced with spending a lot of your time educating others because they haven't necessarily gone on this Triz or TrizIT journey with you. So what is TrizIT? If that was Triz, if it's the theory of solving problems inventively in Russian, the theory of inventive problem solving from an engineering context, what we've done with TrizIT is we've taken that and we have advanced it and made it specific to information technology. So it really is a framework or a way to frame how to move information technology systems forward. You'll see on this slide we have 4 key terms. We have supersystem, system, subsystem, and then action. And you can see it says that Super systems are made up of systems and subsystems, and the actions performed. In TrizIT, one of the framing concepts is that actions are only performed by subsystems. This is because the the definition of whether we're looking at a system, a supersystem, or a subsystem is all about perspective. So one of the first paradigm changes that you take on as you start to apply TrizIT is moving up and down the continuum, finding the right perspective or the right paradigm to look at the particular problem that you're trying to tackle. And another way to put that would be the particular system that you're trying to move forward, the particular contradiction that you're trying to address, so on and so forth. So for example, in an IT system, we have databases, we have data, we have users, we have servers, we have clients, we have operating systems, we have all these different pieces. We could look at a point of sale system. Let's just say the point of sale system that Best Buy uses. That could be a system. We look at it from an enterprise standpoint, and the point of sale system is a system inside of Best Buy. However, if we're at a particular store and we're at the cash register and it's not working, a paradigm we could take to tackle that problem would be that the cash register is a system, part of the overall Best Buy point of sale super system, which is all of the different pieces, the database and the network and all of those pieces. And we can move up and down that. The important thing to take away from that is when addressing a contradiction or when applying TrizIT, we first have to frame our perspective and define what we're calling a system, what we're calling a subsystem, and what we're calling a supersystem. So if that is the system concept inside of TrizIT, the framing components are what we call the system patterns, which I'll go over in detail on the next slide, and the solution models. Now, these solution models are derivatives of the original engineering models that have been applied to the information technology toolkit, the types of information technology challenges, contradictions that we run into, and they have been modernized to address current technology trends and patterns. The book goes into great detail on each of these patterns. These emerged from my research as I was working to use. My initial instinct was to attempt to use Triz inside of information technology. I found that while there was potential, it wasn't specific enough, and everything required layers of translation before I could start to address specific challenges, specific contradictions. As I translated it and applied modern IT best practices, what I discovered was very fascinating. In Triz, these are called laws. They're not really laws, though. They're more patterns. And what I found was there were 4 elements to the life cycle of a system. Now, remember on that first slide, I gave the Best Buy example. I don't know if it was a good example or not, but the idea is that your context and perspective of where you are inside of information technology leads to the categorization of what is a system, what is a subsystem, and what is a supersystem. Dealing with a system, which is always the active current kit under examination, what I found was there were alpha patterns as subsystems came together to form systems. There were epsilon patterns. These are emergent patterns as the system is forming and improving. There's the Dow patterns, which is primarily through the life cycle, and this is the main useful time period of a system. And then there was the omega pattern, or the end pattern, of what happened to a system towards the end of its life cycle. So the alpha patterns are emergent patterns, is an emergent pattern when subsystems are forming into a system. Epsilon is it is improving, Tau is evolving, and then omega as it is transitioning to become a subsystem in a larger system. So the book goes through these. I'll probably do another PowerPoint where I talk to these specifically. You've had time to read them up there. It's a fascinating way of looking at IT systems. And what I found was if I could identify where the system I was dealing with was in its life cycle, it led me to specific models quicker that I could then use to address the contradictions in the system and help move it forward. So now the solution process. We've talked about what it is that we're dealing with, which is supersystems, systems, and subsystems. We've talked about how we frame them and define them. We've talked about the driving elements, right? The solution models and the system patterns. Now, the other thing that TrizIT brings to the table is a simple process that is based in fact, not politics. One of the other challenges, and one of the reasons why I developed TrizIT, is I found that a lot of IT, information technology solutions were political solutions. They weren't scientific solutions. And it leads IT groups into some funny places when we have to decide and pretend to believe something or assume something as what we believe, independent of the facts or what we view a potential best practice might be. So this is a very simple solutioning process. It depends on a couple things. The ability to define a problem that you're trying to solve. The ability to then use words to explain what the ideal result of the solution is. You'll find this is missed almost every time. We will decide this is what the problem is, and this is how we should address it, but we never take the time to identify what is the best possible outcome that we're shooting for. We call that the ideal final result. I probably will do a PowerPoint on that. Also, the book covers it in detail. There's some loose mathematics, algebra that goes with it to kind of prove it out. But it's just a way of getting agreement on what it is we're trying to do. So if we're building a website, for example, and the goal of the website is to sell widgets, then the ideal final result would be that we have a website that sells the most widgets it could possibly sell. If the goal of the website is to be aesthetically beautiful, or maybe even the most aesthetically beautiful website that we've ever seen, and then we build a website that is the most aesthetically beautiful, then that is the ideal final result. We might discover that we are not trying to build a website that maximizes widget sales and is the most aesthetically beautiful. Some people might want one, some people might want the other. By identifying this ideal final result, we quickly have alignment around what it is we're trying to do. And another foundational premise is that smart, reasonable people, given the same data and the same desired result, will generally reach the same conclusion. So you'll find a lot of clutter falls away. Third is to determine the contradiction that interferes with us achieving that final result. The fourth is to select models and come up with solutions that remove that contradiction in an expeditious way, using first resources that are easily available to us. And we do all of this in a very scientific approach. We deal with factual information. We focus on root cause analysis, and we develop solutions based on facts and identifiable patterns, not politics or opinions or what I call the religion of tools, which is you ask a Java developer a question, you're going to get a Java developed solution. We want to make sure that before we assume any of that, we deal with facts, patterns, and we do it in a scientific way as opposed to a political or an emotional way. That third step identifying our specific model, the way we're going to improve the system or deal with the contradiction. We call that innovation. Innovation is different than invention. Invention is creating something new or that is unique to the system, something that did not exist in the system when you attempted to solve this particular problem. Innovation is changing the outputs of the system, eliminating harmful effects, using the tools available to us, using the system and the subsystems within it. The model is basically simple. We're trying to get over the wall. We have a specific contradiction. Again, that term is defined in the book in great detail. It's a unchanged term from TRIZ, so TRIZ and TrizIT use contradiction in the same way. Once we do define that contradiction, we look to that generic set of solutions that I talked about. Each one of those is outlined in the book. We adopt the one that we believe fits the model we're dealing with. We pull that down. We see if there's a specific solution there. If there is, and it eliminates, it increases the benefits of the system while reducing the cost of the system or reducing harmful effects of the system, then we know that we have a good solution and that we have just innovated part of the system. The final piece to this is context, the information technology context. Innovation is a great, wonderful thing, but we don't innovate for the purpose of innovation. We do it because we're operating in either, what Michael Porter calls the value chain, which has two pieces. It has a demand chain piece and a supply chain piece. His probably driving contribution is identification of the demand chain. We know what a supply chain is. That logistical management has been around for a while. Understanding, though, that there are both of these pieces is an important part to coming up with information technology solutions, and it's an important piece of the framework and the ideal result that we talked about earlier. So the last piece to this is identifying, are we dealing with a demand chain problem or a supply chain problem? And then you'll see on the slide there's just a few ideas of the types of things that we're looking to improve. I don't actually have it on a slide in this deck. It's in another deck. It's in the book. But when we come up with an innovative solution, we improve the benefits of a system while reducing either the cost of the system or the harmful effects of the system, or both. And that applies then to value, which is a term that we use synonymously with the value chain. We're providing value back into the value chain, either from a demand chain standpoint or a supply chain standpoint. Okay, that's a quick, in air quotes, I'm looking up at the clock and it's about 20 minutes. We didn't get into any of the actual content of TrizIT. We just went over some of the framing principles of TrizIT. And I think you can see by looking at some of the slides or going through this again, one of the goals here is that we're bringing a best practice methodology and toolkit to solving technically complex problems that often get either minimized or become clouded in the broader canvas of the other things that are going on. So TrizIT provides us tools and focus in a way to tackle these problems that is where smart people can look at our analysis and reach the same conclusion, which is generally the best place you can be from an IT standpoint. So often we come up with answers that the next person coming in is comfortable having a different view of, generally for political reasons as opposed to scientific or engineering reasons. Here we've eliminated that, and we've also allowed us to focus, and we bring some good tools to the table to tackle some of these challenges. So hopefully this has been interesting. Quick framing of the TrizIT methodology or the TrizIT framework. And of course, as I said in the opening, and I will say all the time, the book is available on Amazon, and you can buy it with one click if you want. Thanks a lot. Bye.